Okie dokie. In this problem, they say, which of the following equations describes a line that contains this point and is parallel to the line with this equation? So to be parallel to this line means that our line that we are looking for will have the same slope as this line. So what's the slope of this line? This line has a slope of 9/2 because it's in the form of mx plus b. So the value that is multiplied by the x is our slope. So because the slope of this line is 9/2, and because our line needs to be parallel to that line, then our line will also have a slope of 9/2. So which of these equations can we eliminate because they don't have slopes of 9/2? This one, and we're left with 9/2 and 9/2, so both those have slopes of 9/2. Now, let's take the approach of plugging and chugging. What we can do, since we know that our line should contain the point -1, 1, if we plug in -1 for the x value into, say, this equation here, and calculate this, we should get an output of 1, the y value that matches -1, right? That corresponds to an x value of -1. So let's test out equation C here, and we're plugging in -1 as the x value, and we're plugging in -1 as the x value to test if this ordered pair is on this line. So we get -9/2 plus 11/2. These have the same denominator, so we can really just add their numerators. So -9 plus 11 is 2. We leave it over 2. 2/2 is 1. So what this says is when we plugged in -1 for the x value, we got a y value of 1, which is exactly what this ordered pair is. All right? So C is our answer. All right, example number 2 here, we're going to use a similar but slightly different method. So first thing, they say which of the following equations describes a line that contains this point and is parallel to the line with the equation 2x minus 5/2. So parallel to the line, we are still going to use the slope of this line. So the slope of this line is 2. Therefore, the slope of our line that we are looking for should also be 2. But what do you notice? All these equations have a slope of 2. So we're going to take the approach of, instead of plugging and chugging, we're going to use point slope form. We've addressed this in one other video. I can't recall which one right now, but it's helpful to know point slope form if it comes up in any other scenario. So point slope form is where you were given a point, which we will call x1, y1, and you were given a slope, which we have just identified as 2, and we're basically just going to plug them in to this structure here, leaving y as y and x as x. So y minus y1, which is -1, equals m, which is 2, our slope. X stays as x, and we're subtracting x1, which is 1. So just like that, we have an equation of a line. So now our goal is really just to solve for y and simplify. So let's simplify the left side first. Y minus -1 is y plus 1, and then distribute the 2 here and here. We get 2x minus 2, and then we solve for y by subtracting 1, and we get -2 minus 1, which is -3. So 2x minus 3 should be our result. So just like that, we find our answer without having to do a bunch of plugging and chugging. And again, this is using the point slope form of a line. Hope that makes sense. Here's a glance at both problems. If you have any questions, please let me know.